Okay, what's up guys? Today I'm going to do my best shot to tell you how to find the area of a regular polygon. Now, up here in the corner I have how many sides a polygon has. This one has 5, making it a pentagon. And every side is 20 feet. You don't need to go around screwing around, put 20s on all the sides. Okay, it's a regular polygon. Every side's, all these are regular polygons. Now the area of a regular polygon is found using this formula here. I call it S times N times A and then divided by 2. Now you're wondering what's S and what's N and what's A. S is the side length, okay? So we have a side length of 20, so ditch that S and put 20. N is the number of sides, which we know is 5, okay? Now A stands for apothem. Now you're wondering, if you're not in geometry, you're probably wondering what the heck's an apothem. It's from the center, okay? It's from the center down to one of the sides, how long that is. Now, finding that can be a trick, okay? So here's how to find how long that is, okay? What you do is you're going to make a centered triangle. Now this triangle I just made, there's an angle to that. I formed an angle right there. To find the degrees in that angle, you always take 360 degrees because it's like a circle, okay? Because it can be done on any side, so then all of them form a 360. They go all the way around. But that needs to be divided by how many sides there are, because that's how many of those triangles would be out of the 360. So I'm going to divide that by 5, and 360 divided by 5 is 72. Put 72 right there, though. Now, after that has been done, we've cut that angle 72 into 2 equal halves. So divide that by 2, because that's half, and that's 36 degrees. So we put 36 degrees inside there. Now, also, I have a right triangle here, and the base of that triangle is just half of 20, which would be 10. Okay. So again, draw your apothem. To find the big angle, you take 360 divided by the number of sides, and then you divide that in half, and that's your angle. And then you always form a right angle here because it's perpendicular, and then half of 20. Now, just draw that triangle, draw that right triangle off to the down here. Okay, and we know that it has a base of 10 and 36 degrees up here. And I will be able to find that apothem by using my trig ratios. Okay, actually you're going to use the same sine, cosine, tangent, but you're going to use the same one every time. Okay. Now, that's your H. And by the way, in the parentheses we use 36 degrees because that's the reference. And then, oh yeah, also by the way, erase your 10, put 10 outside here. I want the sides outside. Okay, 36 degrees, so my O is 10, and my A is the adjacent side, but it's also known as the apothem, okay? So I have an O of 10, because again, that's what I have here, and that's just the apothem, and I need to find my A. So O and A is going to be tangent, and I put O over A. Okay, so O can be replaced with 10, and that allows me to find A. Now, circle the diagonal that is opposite the A, and multiply that. 1 times 10 is 10, and I divide 10 then by tan 36. Okay, and that's my apothem, whatever that is. Okay, so 10. It's kind of nice because adjacent and apothem have the same letter. They start with the same letter. So 10 divided by tan 36 is 13.76. So that is your apothem. Okay, and now I'm ready to go. I take 20 times 5 times 13.76, and then divided by 2 is 688. So the area approximately is 688, and since the unit's feet, it's square feet. Okay, I'm going to do 3 more yellows in the back. Okay, once again, the formula we start with is S times N times A, all divided by 2. And we know the S and the N right away. The S is 12. The N is how many sides it has. This has 6. It's a hexagon. Okay. Now the apothem. So that's from the center on down. That's figuring how long that is. Okay. Then I make a centered triangle using the 2 vertices here. And again, to find the outside angle, the whole angle, we take 360 degrees and divide by the number of sides, because that's how many of those triangles we could fit in there. Divided by 6 is 60. Now we divide the 60 by 2, and that's 30. So 30 degrees. Now also I have a right angle, and I know from here to here would be half of 12, which is 6. Okay. So I'm going to simply trace that exactly like it looks here. So we have 6 outside and a 30-degree angle here. Okay, and now I set up my ratios to find this side here, because that is my apothem right there. Okay, so I use 30 degrees over 1. And again, I have H, which I don't care about really. Across from 30 is my O, which I have 6, so I need O. This is my A, which I desperately need to find. So again, O and A is the tangent function. That's OA. Replace the O with 6. And A is going to equal whatever 1 times 6, which is 6, divided by tan 30 is. Okay. So 6 divided by tan 30 is 10.39. So I multiply 12 by 6 by 10.39. Find that product, but that has to be divided by 2 then. And the area is 374.04. And we're dealing with feet again, so it's square feet because it's area inside. Okay, my next one. Write that formula, S times N times A divided by 2. S is the side length, which is 4. N is how many sides we have to the polygon. It's an octagon, so it's 8. Now it's time to find the apothem. Okay. So again, what is the apothem? It's from the center on down. Okay, that's what I need to figure out. Okay, I draw a centered triangle. And again, we always take 360 degrees divided by the number of sides, which is 8. Okay. That gives me what the whole triangle is. Okay. 45. Okay. And then we need to divide that in half. This is going to be a decimal because it's an odd. 45 divided by 2 is 22.5. So I'll just put that in here. 22.5. Okay. Degrees. Because I can't really write it horizontally. Again, we have a right angle, and that side of 4 is now split in half to make 2. Okay. So trace that. Remember, that's what we want to figure out. Just separate that triangle from all the rest of that garbage. Okay. We have 22.5 as the angle up here. And we also know that the side length is 2. Okay. So now I go to my trig ratios. And I'll be using 22.5 degrees as my reference. Okay. So that's the hypotenuse, but I don't really care about that. That's my opposite, so I know that's 2. And This is the adjacent, which I want to figure out. So again, it's tangent. That's O over A, okay? So my O is 2. My A then stays A, because that's what I'm trying to figure out. So I take 2 times 1, which is 2, and divided by the tan of 22.5 degrees. Tangent 22.5. So 2 divided by tan 22.5 is 4.83, and that is the apothem. So find the product of those 3 factors, and that's 77.28, and that would be square feet. Okay, and the last one I'm going to be doing. S times N times A divided by 2. So again, the side length's 10. The number of sides it has is 7, and then the apothem. So again, center on down, trying to figure that out. I make a centered triangle, and I'm dividing 360 degrees by how many sides we have, which is 7, because that coincidentally, not coincidentally, is how many of those triangles I can fit in there. So that'd be 51.4 degrees. But again, that has to now be divided by 2, because I have split that 51.4 degree angle into 2 equal halves, even though it might not look like it. Okay, 25.7. Okay, and I'll put that sideways. Okay, and again, we also know that's a right angle, and we've cut that in half to make 5. So if I know, so that's pretty much all I need, and I'll be able to use my trig, my tangent, to find the apothem. Remember, the straight up and down side is your apothem. That's what you need to figure out. And you have 5, and then 22.5 degrees. Okay. So again, I set up my ratios. 22.5 degrees is my reference angle. And I've got my hypotenuse, which I really don't care about. Okay. And then opposite is 5, and then my question mark's the A. So again, it's tangent again. It's going to be tangent every time. Okay, and that's O over A, and I know my O is 5, and I don't know my A. So here's my A. So A equals the product of 5 and 1, which is 5, divided by tan 22.5. 12.07. Okay, now that is my apothem. Now I can figure this out. 10 times 7 times 12.07 divided by 2, 422.45. That's square feet. All right, guys, let's really have to say on that today. You have a decagon on the last one. Okay.